need to do is we need to solve something. Whatever the problem tells us, we need to solve it. So for example, the cat. Cat's weight, the force of gravity, is 90 newtons. Okay, so I'm going to write down 90 newtons for force of gravity. What is the normal force acting on the cat? So I've got the force of gravity to be 90. I need to know what the normal force is acting on the cat. Now, some of you may automatically know this off the top of your head. You look at it, you're like, bam, it's this number. Don't say it if you do. Shh. Don't want to ruin it for the other people. Okay? All right. So how do I figure this out? If it's not obvious to you, how do I figure this out? So there's an equation that we kind of talked about, but I'm going to give it to you in a different way, and this is how you're going to see it on the test. It's this. F net equals, get ready, sigma F. Okay, what in the blue blazes is this sigma business? So first of all, sigma is a Greek letter, capital sigma. This is not lowercase sigma. This is capital sigma. It means sum. In other words, add. What this equation says is to get the net force, you add the forces. That's what this equation is. To get the net force, you add the forces. That's it. Well, guess what? We already figured out the net force. We already figured out that it's 0. So F net is 0. So what do? We add together the forces. All of the positive forces, which are generally thought of as up, and then all the negative forces, which are generally thought of as down. So I would say up, which is Fn, I don't know what it is, plus negative 90, because it's in the opposite direction. So you would add 90 to the other side, and you've got what some people saw right away, which was that the normal force is 90. Not to toot my own horn, but I knew it immediately. And here's how I knew. The net force was 0. That means the forces are balanced. If the down force is 90, the up has to also be 90 to balance it out. That's how I knew. But I want to make sure you see this. If you don't know, if it's not obvious, you can solve this anyway every time. So you do not have to stress, be like, well, I didn't know that. That's fine. Net force equals the sum of the forces. Normal plus gravity. Okay? I'm going to have you do the same thing here. I want you to try numbers 2 and 3. I want you to do the same thing. So in number 2, car has an applied force of 700, frictional force of 300. Find the magnitude of the air resistance. Okay, try that one. And then see, well, let's just do this one next. Let's just try number 2. You can go on to 3 if you finish it, but I want you to try C on number 2. So find the magnitude of air resistance. Okay? See if you can figure it out. Don't forget the net force is 0. That matters. See if you can figure it out. All right, Matthew. How did you set this up? What did you do? Oh, you're going to ask me? And I didn't come? Oh, I'm sorry. All right. So here's where you should start. Ready? He's ready. Start with what the net force is. So what is the net force for this problem? 0. Okay. So that's where we're starting. Now we use the net force equation, which is add all the forces. Now we've got 5 of them. Now I didn't mention this before, but I do want to mention this now. You're worried about in the direction of motion. So Matthew, which direction is the car going? Yeah, to the right, yeah. So I'm worried about forwards and backwards. So I'm not worried about normal. I'm not worried about gravity. So when I'm adding these forces up, I'm only adding these three. Applied, friction, drag. Those are the only thing I'm adding up. Okay, with me? Okay, good. So I'm going to say 700. So the applied force has a value of 700. Friction has a force of 300. And I want to know what the value for drag is. Okay, so I would say 700 plus 300 plus drag. Okay, Brady, I did something wrong. What did I do wrong? So I've got 700 plus 300 plus drag. Look at the arrows. What's wrong with how I did this? Which means something's got to be negative. Yes. So you could either say minus, or what I'm doing to try to be more consistent here, plus a negative 300. Plus a negative 300. So 700 minus 300 is 400. You got to subtract that to the other side to get it away from drag, and you get drag equals negative 400. Okay, there we go. One more. Okay, C. The frictional force and the air resistance are the same as last problem. So drag is 400. Friction is 300. The applied force, however, is 900. I want to know what the net force is. This is different. This is different than what we've done. We're solving for net force. All these other problems, the net force was 0. Okay? This time you're solving for net force. Take a minute, see if you can figure it out. See if you can figure out what the net force is here. Why? Why am I adding them up? Good. What am I solving for? Yes, and that's how you find the net force. So I want to make sure you understand why you're adding them. You're adding them because you're trying to find the net force, and the equation for net force is the sum of all the forces. Okay? So what are the forces? 900 to the right plus 400 left, so negative 400, plus 300 left, so negative 300. Equals, final answer, 200 newtons. Woohoo! All right. Any questions? Yeah. Yeah, you be careful. Yeah, it's the unit for force, so make sure you're putting it on there. You don't have to here. Just make sure your final answer has it. Okay, we are almost done. Almost done.